Hi everyone, today we will do practical 6 which is phylogenetic tree. The learning outcome for this practical is firstly to visualize multiple sequence alignment as phylogenetic tree. Next, to understand the evolution and relation of 16S rRNA sequence throughout different branches of the tree of life. So the reason to do phylogeny is to infer the evolutionary relationship. For example, if we have sequences, we might want it will show how different they are from each other, and if they are different from each other, how they can be clustered. So in order to build this phylogenetic tree, we will have 5 steps. Firstly is to select sequence. Next is to build an NMSA. Step number 3 is to select substitution model. Number 4 is to build the tree. We have 4 types of tree if you can see in the lecture note. The step number 3 and number 4 we will do in practical 6.3 later. And the last step is to validate the tree. Okay. If you see in the background information, we use 16S rRNA gene sequence. Okay, what is 16S rRNA gene? It is referred to subunit that used in translation process, which is ribosome. If you know, ribosome have 16S subunit and 20S subunit, and this ribosome, 16S ribosome, is different between bacteria. So it's different at bacterial level, and this can be used to find distantly related species, bacterial species. Okay. In here also we have NJ, which is neighbor joining, and also UPGMA. What is this? Both of these methods are always involved in calculation. We will see later how the calculation that it will show. And next we have minimum evolution and maximum parsimony. This is part of character-based tree where number is not counted but it is extrapolated. Both of these methods can be used to build tree, but use different method. Okay, now we will move on to practical 6.1, which is how to create a full-length 16S rRNA gene sequence. Actually, this method is similarly to practical 2 that we did before, but anyway, I will show how to do it. Okay. Firstly, to upload your forward and reverse sequence of 16S rRNA gene into bioedit. Okay, like usually we will not take the end one, so we will take after the end. Okay, so here the end is underlined, so we take the one that is not underlined. So for forward, I will take from T, okay, to G here, and for reverse, I will take from T to A here. Okay, for me to make it easier, I put in the word. So just now the instruction is to paste in bioedit. So I will copy the forward one. Okay, I'll copy. Then I will open my bioedit. Okay, I will choose click file, new alignment. Okay, then sequence, new sequence. I will paste the forward first. Okay, I name it as forward. Start is DNA. Apply and close. For reverse also, I will do the same thing. Select all, copy. Okay, then I open my bioedit. Sequence, new sequence. I will paste it. Then this one is reverse. Select it as DNA also. Apply and close. Then I will select my reverse sequence. I will select sequence, then I will choose nucleic acid, then I will reverse complement, click reverse complement. Now the reverse sequence is complement to the forward sequence. So the next step is I will click both forward and reverse. I will choose accessory application, then click at cat contain assembly program. So then click run application, then just click enter. Okay, here they already gave the config sequence, so click here, put edit, click edit, and then copy the sequence to FASTA format. Okay, and then I already have here the config sequence. Okay, by having this config sequence is actually we already done with our practical 6.1. Next, we move on to practical 6.2. Okay, as for practical 6.2, firstly, you must open BLAST, then retrieve the full length of 16S rRNA gene that we get from the bioedit just now. Okay, then we must, okay, we open first. Okay, I will open BLAST and CBR. Okay. Click nucleotide, and just now I already have the sequence with me, the full sequence. Copy. Okay, copy, and I will paste it here. Okay, but here you must select reference RNA sequence, because just now we use 16 as rRNA gene sequence. So then BLAST. Okay, while waiting for the BLAST, okay, we must check the sequence producing significant alignments and download the sequence into FASTA format. Minimum is 10 alignments. So by download the FASTA format, we will finish our practical 6.2. Then we go back to the still waiting. I will stop first and start back. Okay, now I already get the result. Okay, firstly you must unselect all. So here we must choose percentage percentage identity that is far a bit from each other. Cannot choose that is close close to each other, because we want to build an optimal. In order to build an optimal tree, the percentage identity must far from each other. But unfortunately here the percentage identity are all above 90%, so we must choose 10. So firstly I will choose the 98%. Okay, 6, so must choose 10. 3, 4, 5, 5, 6, 7, 8, 9, 10. Choose this one. Okay, now I already have 10. I already select 10 sequence here to download, as this last step is to download into FASTA format, so I download here. Okay, this one, it will give all the 10 sequence alignment. Okay, by having this, we complete our practical 6.2. Okay, now for practical 6.3, we will build phylogenetic tree. So as you know, phylogenetic tree is evolutionary tree. We show the evolutionary relationship various biological species for this practical use bacteria larvae, and will differentiate between class 16S gene sequence. Okay, firstly must click the URL. So I already clicked there. Then select sequence either protein DNA and then upload the file that containing just now that we download 16S the sequence 16S RNA gene sequence from the blast result. Okay, so here we must choose DNA even though just now we use 16S RNA gene sequence. So here we choose upload file. Okay, just now the one that I download the that contain the 10 alignment is T6. Okay, I upload that one. And then we can change actually the parameters, the output format. But we as a beginner, we just like use it. This one be notified by email. Sometimes if we did a long sequence, so it will take time, so they will not notify us by email. But we just use now 10 alignment, so just press submit. So waiting. Okay, now I already get the result. Okay, the result I get is like this. This is like alignment number 1, number 2, number 3, number 4, number 5, 6, 7, 8, 9, 10. Okay, this one is also alignment number 1, 2, 3, 4, 5, 6, 7. It's actually this is not alignment number 1. This is also alignment number 1. It's just continuity of the alignment. Actually, we have two type of tree, guide tree and phylogenetic tree. Okay, this guide tree is actually generated from pairwise alignment. Okay, when we get the score from the pairwise alignment, the score will be used to generate this guide tree. But by using this guide tree, we will use it to build MSA. After get the MSA, we will select the substitution method and we will create this phylogenetic tree. Okay, we will get this phylogenetic tree. As I mentioned just now, neighbor joining tree, it involves calculation, right? So the calculation involved here is actually it calculate the distance here. Okay, it calculate the distance from one another. Okay, here is like I want to explain the terms. This is multiplication in which it has 3 branches, and the optimal one is when we get bifurcation, which is 2 branch. Okay, when we have multiplication, it is because they are so similar or the sequence is close to each other. So there is no enough data to detect which one comes first, the ancestor. So it's like both of that is come directly. Both are at the same level. You cannot detect which one is the ancestor. Okay, like this one, the distance from each other. Okay, you can see here 0.0186. It is close to this one. Okay, 0.01248. But the distance between this one and this one is much more far. Okay, that's why. Okay, it's explained in the phylogenetic tree. Okay. Between the guide tree and phylogenetic tree, we actually will see the phylogenetic tree. Okay, based on the result of the neighbor joining tree. Okay, we will analyze the distance between each other. Okay, that